Great. We're welcoming Soulaine, and well, basically the floor is yours for half an hour.
Okay, great. Thank you so much for having me. I don't have that much time. Hi, everyone. My name is Soulaine. I am a software developer at the Naturalis Biodiversity Center in Leiden in the Netherlands. And I'm really, really excited to talk to you about a project that we've been working on called DiSSCo, which is the Distributed System of Scientific Collections. So let's get started. Here is what I'm going to talk about today. First, I'm going to talk a little bit about what a natural history collection is, or natural science collection is, and why they are important, and the obstacles that we might face with digitizing them. Then I'm going to start talking about DiSSCo, my project, and the kinds of problems that we can address to help this process and make data more accessible. Then I'm going to talk about enriching the data, first by humans through annotations, and then by machines. Lastly, I'm just going to give a little bit of a what's next for DiSSCo. So what is a natural history collection? If you've ever been to a natural history museum, or maybe a botanical garden, sometimes a zoo or an aquarium, these kinds of institutions, often the public-facing part is only the tip of the iceberg. And these institutions host these really rich and valuable collections of plants and animals and fungi and geological collections. And it's this really rich historical record going back hundreds of years when they were collected, up until the present. A specimen will have important information like what is it, so the taxonomy, where was it found, so locality data, who collected it, and when it was collected, so you get that historical record. Researchers in biodiversity will rely on these kinds of collections to identify organisms or specimens that they found. And so these kinds of collections, they allow them to determine what it is or if it's something entirely new. And so these natural history collections, they become this really rich reservoir, a really important resource for researchers, not only helping us understand the past, but also inform policy decisions about really important issues like climate change and biodiversity loss. And just sort of dipping our toes, or beginning to talk about why it's important that these are digitized, I've got two example articles here. One is about a research project where they looked at digitized moths from across institutions, and they used that data to confirm a 100-year-old hypothesis about moth coloration. And the second article is from the Museum für Naturkunde in Berlin. Excuse my German. And they did. They looked into their collection, and they found 40 species previously unknown to science. These were just lying around in a box somewhere. And so it's really important that not only are they accessible to researchers to study, but we need to know what is there. And so let's talk about digitizing. Unfortunately, huge parts of the natural science collections across Europe and the world are not digitized. This means that researchers often will have to go to the physical institutions, potentially several institutions, and that costs time, that costs money, that costs carbon, which is something that we want to be aware of in the biodiversity sector. And if things are digitized, that means often these institutions have been doing things differently for hundreds of years. So there's some data disparities, data quirks that each institution has. So that means data wrangling and harmonization, which is a waste of researchers' time. These digitization efforts, when they do happen, it's very difficult to scale up and look at this at a European scale. Expertise, for one, is limited. So like I said, one of the most important things in a specimen is what is it? What is the taxonomy? But we are facing right now a taxonomist shortage, so we don't have the experts to go around to identify all of what we have, and things are going unidentified, even if we are digitizing them. The second thing, of course, it's expensive. These large digitization projects, they are possible for the larger institutions, but smaller collections is a much bigger barrier. And finally, collaboration can be really difficult. often, like I said, you have these data differences between institutions. That means any tools that you make that are designed to help this visualization process, they're siloed to one institution. And so we don't get to collaborate as much. So here is where I finally get to the thing that I am working on. The DiSSCo, it stands for the Distributed System of Scientific Collections, and we are a European-funded in-development research infrastructure. And our goal is to increase access to European natural science collections across Europe, make them fair, make them and support digitization at scale. So I'm going to talk a little bit about where DiSSCo fits into this biodiversity data landscape. So I have my data providers, and that is CMS, which I realize is not a well-known acronym, but it stands for Collection Management System. So these are the digital systems that different institutions would store their data in. And then on the right there, we have data consumers. So we have organizations that aggregate specimen data as well as other kinds of biodiversity data. And so what we envision is DiSSCo sitting in the middle, enriching the data before they get to the data consumers. So what do we do? First, we harmonize all incoming data to OpenDS, which is our in-house data specification based on existing data models. There's a couple of different big data models that you would see in the biodiversity sector, and we say, no, we're going to do one. And of course, we can talk about that XKCD article or that XKCD comic, but we do our best. We assign every individual specimen a digital object identifier. That means that it is a unique identifier for a specimen that is resolvable. It'll always resolve back to DiSSCo, and it'll always resolve back to DiSSCo, and that means that they can be cited individually as part of a research article about an expedition or something like that. We capture provenance, so what has changed in the source system data or beyond. We link data and extend it, so we link it to other institutions or, other infrastructures. Because a specimen is interesting, but it's even more interesting if you can link it to the genomic sequences or the environmental data that it was found in. And so by linking all of these, you get this like extended digital object that is really rich. And finally, annotations, which are made by humans or machines, which is the main thing I'm excited to talk to you about. And so this is the core DiSSCo platform, and on top of it, you can build services that are machine-facing. You can also build services that are human-facing. That's sort of where the distributed comes from. We develop this core data infrastructure, and then our partners are developing different services on top. So, annotations. We use, our annotations are based on the W3C model, and essentially it's its own digital object attached to or associated with the digital specimen or a media object. You can add information, delete information, assess, comment. You say all of that, it becomes, your opinion becomes a separate digital object, and then it will be ready for review. You can annotate the entire specimen or a specific part, like the taxonomy. If you have a media object, you can annotate a region of interest, such as indicating that this is the antenna. And so the process, this is how we envision the process to be going. So anything that is an adding, a deleting, or an editing annotation, even though that information is stored in its own digital object, eventually we want it to modify the target. So we don't want an annotation saying, hey, this field needs to be changed to this. We want to actually transform the object. So a user would select a specimen, annotate it. The annotation is discussed and approved by the collection manager or an expert. Then the specimen becomes updated with new information, and that new information is published both back to the source system, the institution, and also to the data aggregators on the other side. Now, this looks great. The red box is in progress. This is our main goal for 2026. So in DiSSCo, we can capture the annotations from experts right now. So we have been partnering with researchers at Naturalis And this is a really good example that really helped us streamline our annotation process for users. So the Naturalis Papillote project was a digitization project at our institution of 300,000 butterflies stored in papillotes, which are the triangular envelopes that you saw. So we had papillons in papillotes. It was powered by volunteers. So these people, they took pictures, they extracted these very delicate, often centuries-old butterflies with tweezers. They photographed them with the scale. They transcribed the date, the location, the collection ID. But there's and any other information that was with the butterfly. But there's an important piece missing. It's the taxonomy. Now, if we had an army of taxonomists doing our digitization, we would be a very lucky institution. But instead, unfortunately, our collection managers were sending spreadsheets back and forth by email with, please fill out this, the taxonomy for this specimen, which obviously is so prone to human error. You want to make sure that you're using you're identifying the right specimen, and what if you do a typo? And then people would take those spreadsheets and then manually insert them back into our collection management system. So this process has much to be improved. So working with our target users, we identified a couple of ways that DiSSCo can help. The first was reducing human error with taxonomy. So it would be really helpful if we could automatically fill out taxonomy instead of relying on people not only getting the specimen name right, but also the family, the genus, the order, the class, all of the higher levels of taxonomy. We also want to capture transparency. So in the future, when this annotation is accepted, we still want to know, well, who made the annotation and who accepted it? Why is the specimen like this now? And we want an unambiguous process. So we want to really be sure of what specimen you're actually identifying, so the annotation is attached to the specimen. Okay, so here I should have a video, but I thought, it's FOSDEM, let's do a live demo, let's live a little bit. So here we are. Hang on, I'm going to go back. Of course, this is where I tried this 10 minutes ago, but of course it's the Wi-Fi. Oh my goodness. Of course, we're living too much. Okay, well, we're gonna go back to, okay. I'm sorry too. Yeah. I think it might be a Wi-Fi issue.
Change your Wi-Fi.
Yeah.
For them, not the effects.
Oh. We tempted fate too much. Okay, here we go. Yes, thank you for your patience. Okay, so this is the homepage of our sandbox environment for Discover, which is the human interface for DiSSCo. So I can choose from a couple of different domains. I'm just going to click search, and this will show us a couple of top specimens. And so what I'm interested in, if I'm a taxonomist and a collection manager has asked me, hey, can you please identify these butterflies from this data set? I can go into source system, and I click on Naturalis Biodiversity Center Lepidoptera, the butterflies. That is the name of the data set we want to identify. And maybe because we're only interested in the, we're only interested in specimens that are missing a taxonomy, so let's go no genus. And let's click Has Media because the pictures are pretty. Okay. So this is the main specimen landing page. You can have basic specimen information here. Sometimes if there are coordinates in the data, you have a geographical map that is rendered. It has information about the specimen host. This is all data that we've transformed from the source system, so we don't generally add anything new. you see I'm logged in here. I need to be logged in with an ORCID ID to make an annotation. And then I click Annotate on Accepted Identification. This is the taxonomy block. So we're interested in adding some more information. Now, unfortunately, I am not a butterfly expert, and I was trying to think of like a butterfly scientific name. The only thing I know is like bombus, which is a bumblebee. So don't accept this annotation. But let's say I am an expert, and I'm certain this is a bumblebee. And so what you can see here, oh, this is an avis. This is a bird, actually. I'm not very good at my job. I'm a bad taxonomist. But what you've seen there is that it's automatically filled out the genus and the family, and then also the class and the phylum as well. So it's filled up all of the higher levels of taxonomy. All I've had to do is fill out the scientific name. I click Review on the annotation, and I can see all of the things that have changed. So these are the differences between what the existing data is and what I am saying it is. And I submit the annotation, and then I have something that is marked pending. And eventually, a collection manager should come and see this and say, that's crazy, that's not a bird, reject. So that is my demo. Okay, so it's great that we are doing annotations with humans. What if we could get machines to do the work as well? We call these services that make annotations Machine Annotation Services, or MAS. So if I start saying MAS in this presentation, you know what I mean now. It's great to use machines to do the work because they get to do the boring stuff. We save our precious, precious taxonomists to do the complicated edge cases. Like I said, DiSSCo has one single data model. That means a service adapted for DiSSCo can be applied to any institution that we partner with. It lets us reuse work, so researchers aren't constantly developing their own tools, but instead they can select from a wide, hopefully wide platform of services. And we have a modular design. So DiSSCo was designed with the idea that other services should plug into the platform. So that means that anyone can adapt an existing service to DiSSCo, which I can show you very briefly here. What is in blue here, or in the box, is the core DiSSCo architecture. So when a user schedules a MAS, a machine annotation service, that spins up what we call a wrapper service. And all this does is it takes the job, and then it extracts important information, and it sends it to a value service. And this could be anything. This could be a complicated and sophisticated AI model that identifies species or reads labels, or it could be something as silly as a spell checker. Not silly, the spelling is important, but so it receives that request, it sends out a result, and then this wrapper service takes those results and formats it as a DiSSCo annotation. So we designed this system, but we'd only ever developed masses ourselves. So we partnered with Senckenberg to see, hey, is this documentation good enough? Can you do this as well? And so in December 2024, they were able to integrate a service that they developed, an IAM model that captured pixel-level masks on herbarium sheets. And we integrated that with DiSSCo in our acceptance environment. And then we were feeling really confident, and we had a hackathon in 2025 with 3 days, 3 teams, and 3 machine annotation services were able to be integrated in DiSSCo at the time. What we were really testing was the integration process, so how was the documentation, what bumps do people hit. These masses are hackathon quality, but we were really happy with the results that people were able to so quickly integrate it into our system. Finally, the most recent hackathon we had was in April 2025. This was a project based on the GBIF capacity building project of AI for specimen labels, which uses AI to read specimen labels. And now, if we can get this into our pipeline, it really helps. It can really help this digitalization process because all you need is a photo and an AI model reading the labels and creating these annotations. And then it's up to a human to correct any mistakes that it might make and accept or decline those annotations. I did record this one because the API is a little slow. But here I have a media object that that's a pity, that I'm looking at. There's a label that we want to read. And so I go to the top button there that says, that's a pity. It's sorry, it's a little cut off, but I am selecting the machine annotation service I am interested in running. It's called SPLAT, the Specimen Automated Label Transcription. And then I run it, and then this wrapper service gets spun up in the DiSSCo architecture, and then that wrapper service calls the SPLAT API, and then the SPLAT API returns a result, and the wrapper service gives us an annotation. So if I go back to the specimen, and I click on Annotate here, I can see that it has created several annotations about what is read from the label. And with this one, results may vary. But it was a really good proof of concept, and we want to partner further with other such services. So lastly, I just want to talk about what is next for DiSSCo. We want to work on accepting annotations. That's a huge part of what we are, it's a huge part of our value offering. We want to be able to export the annotations and publish them. We want to continue our collaboration with researchers, and we want to become a ERIC, which is a European Research Infrastructure, it essentially means that we are a legal entity, and then we can make SLAs with other mass providers. I want to thank the people on this slide, the development team, the collaborators, anyone at Naturalis that I've ever gotten a coffee with, my colleagues for coming here at 9:30 in the morning. And if you are interested in what we do, we have a GitHub, we have example masses and documentation, more information. The QR code just goes to the slide, so you can click on the links. Thank you so much for your attention. Yeah, that's it.
You can take them as you just repeat them, please.
Yes. Hey.
This is really, really cool. So I'm doing a PhD on all of this exact stuff. This is the best, and I'm a taxonomist as well. So great work.
Thank you for your work.
Trying to ask a question that's like the most general, which is annotations are often wrong, even when people do them afterwards. Are you building an iNaturalist-like way of saying that guy's annotation could be improved?
Okay, so the question, thank you, was, are we developing a service that people can reply to annotations essentially and say, oh, this could be improved? In some regards, yes, you can. So any object in our service can be annotated. So you can annotate an annotation as well. It's also annotations aren't. Who can accept an annotation is still something that everybody wants to know. We're working on a trust model, who has control over the data, who owns the data, but that is something that we're keeping in mind. Also for machine annotation services. So, oh, this machine made a slight mistake. Let's correct it instead of doing it ourselves.
Hi, this is a question from a lapsed taxonomist. So taxonomic architecture changes, right? So new papers come out, they've redefined the phylogeny of something. Does that change get echoed in your architecture?
I'm so glad you asked that question. The question was, taxonomy is always changing, so how do we capture these changes in the architecture? So we use Catalog of Life as a backbone for that. For those that don't know, it is a service that captures taxonomy, and we harmonize everyone to the Catalog of Life's taxonomy. So other institutions might have slight differences in opinions, but we like to have one standard. And so as Catalog of Life releases has new releases, we want to stay up to date with that. I was saying there's a taxonomist shortage, but the last two people have been taxonomists. Where have you been?
When you showed the demo, there was something in the filter and in the data specimen page that was called like meets level or something. What is that?
So in my demo, I showed something called MIDS level in the filters. What is MIDS? MIDS is a in development standard. Yeah, it's still in development. It stands for Minimum Information About a Digital Specimen, MIDS. And essentially, that describes the completeness of a specimen. So if it has an institution ID and a catalog number, we're mid-0. That's the minimum that we'll accept. If it has a little bit more information about locality, a little more rich data, it can get to level 1. And then if it's really complete, it'll get to level 2. And so the standard describes, it's essentially a completeness indicator for a specimen.
So through the annotations, you can bank the level of the mix to one, from one to another, right?
So the question was, can annotations increase MIDS? Yeah, if you're annotating the targeted fields, that's the idea behind DiSSCo is getting more enriched data, so increasing the completeness of the data.
Yeah, so you mentioned the fact that you are getting data out of institutions, existing collections, and that you plan to get those data or annotation back to the original system. So my question is large. You can take whatever details on that. Like how original institutions are considering your work on the DiSSCo platform. And is there tension in there between the original system and yours?
So the question is there tension between the source data system, so these institutions, and what we're doing to the data? I would say no. We're trying to offer them a service and not replace them necessarily. The idea is that we don't want 300 different institutions to make changes. We want to do the changes for them once. I wouldn't say tension, but the question that we still do need to answer is who can accept annotations and who can make these changes. And this is something that we're working with the community to discover, to find a solution that really makes the most sense for the biodiversity research community. Yes?
Are you doing any links to Wikimedia or Wikidata to disambiguate persons or species?
The question is, are we doing any work with Wikimedia or Wikidata to disambiguate persons? Yes. So there are projects that are happening, all over, but specifically at our institution as well. And we would like to use their work and just sort of steal it, adapt it to DiSSCo, and then make it accessible to everyone. Because it is really important that not just the main collector gets credit, but also all of the people who worked with them.
Very quick question. You mentioned doing hackathons.
Yes.
Is it something that's usual? Is it something, is it closed or is it open?
Hackathons, the question was hackathons, and are they regular? Are they closed? Are they open? I would say they are open. They are not regular. This is recorded, but we are hoping to have one this year, but nothing has been set in stone. But yeah, they are, yeah.
Thank you.
Thanks.